banks and banks of humming machinery. I've never seen so many knobs. Here, try that button over there. No. Check that button over there.
This amplifier had been worked on at a hi-fi shop that recently went out of business. I was able to pick it up from the creditors, basically. This was stuff that wasn't picked up. This particular amplifier was in pieces. I got it, put it together, turned it on, went right into Protect, took it apart, inspected everything. Left channel amplifier was an absolute disaster. So here I'm going to show you what I've done thus far and while I wait for some parts to arrive from DigiKey. First of all, these are the parts that I've pulled thus far. We've got 2 output transistors that are failed. We've got a bunch of fuses are blown, literally some of them blown, and a couple diodes are not behaving properly. One of them failed open, the other one shorted. And then obviously this fuse, it's not dead, but someone put a slow blow fuse in place of a normal fuse. So it's a pretty good indication there's something already going wrong, or they're trying to get it to work better. And let me explain a little bit more about that once I aim it at the actual board here. And here we have a good look at the circuit board. So here's what's going on. From what I can see, they've replaced all of these. The blue guys are their replacement resistors. They have replaced this resistor as well. Replaced these 2 transistors and these 2 transistors. Now, and they've replaced all 4 of the output transistors. I can tell by looking at comparing the ones on the right channel. They're a completely different generation, basically, of transistors. So I know they've done those as well. This thing also had notes. Let me grab it. It had a sticky note sitting on it. Replaced outputs, many toasted resistors, something about transistors, still looking for a mystery short. Well, as far as I can tell, there's no mystery short. So here's what I've discovered. Most of these resistors, they put in half-watt resistors in place of what should have been quarter-watt and fusible resistors. So they put fusible ones in, so they're guaranteed to fail open and not create a big bunch of fireworks. So I don't have any fusibles, but as long as you put in the correct rating on your resistors, they generally should fail open. So, you know, I mean, it would be great if I could get the fusible ones, but they're a little harder to find these days. In any case, you don't put in, like this repair place did, you don't put in half-watt resistors. These fail at a much higher current load, so they're not going to act as a fuse and protect the rest of the devices, the rest of the components within the board. So when you do that, it takes more current before they fail, and so you get more and more failures in the board. The other thing I noted on this board is these replacement transistors. They seem to grab whatever parts they had laying around and just throw them in, because specification wise they're not a particularly good match for what was in there. As well, they're mismatched. This pair and this pair of transistors are complementary to each other. They work together in sort of a push-pull sort of situation. So you want them as closely matched as possible specification-wise. And what they put in here are mismatched. These are fairly close. They're at least the same company, same sort of chip, same sort of transistor. One has slightly different specs, but close enough it shouldn't cause a problem. But they're way out of spec for the circuit, for the transistors that had been in there. But this pair, these are completely mismatched. They have totally different specifications. So these two are going to be fighting with each other. So you can see all the red marked. Hopefully you can see all the red marks. These are all the failed components within there, including the ones that I've pulled out. So far as I can tell, now the transistors in question are these two and these two. This pair and this pair are the ones that they replaced. I saw a char mark underneath one of them, so we know why that's failed. The thing is that you can see where all the failures are around here. So this set, they're involved with keeping this system balanced. The other ones that had the big heat sinks on them, these two are involved in driving the output transistors. These ones are all about balancing the voltages between the positive and negative rails, essentially. And that's what's failed. So if you've got transistors that are completely different in their operation, the circuit's going to be naturally unbalanced. As well, I discovered with this transistor having been open, failed open, and this one was allowing current to go the wrong way, you can see there's a path. So that's the sort of thing like it's highly likely the actual failure point for this amplifier may have been that diode. I don't know for sure because I'm not the first one in here, but that diode could have been gone, and they did all this work, but that diode still not allowing current to pass and blew everything up again. So that's what we're doing. I'm going through this amp. I'm just replacing the components that were completely burned out. I have a replacement pair for these transistors. I have ordered some to replace these. I've ordered new outputs. And we will see how this goes. I'm really hopeful that this transistor pair has survived. They've probably taken quite a hit. It appears that they're working okay. I don't have a great replacement for these. I have a set that's very, very close to the specs on these. I actually pulled out of a old Onkyo that was not repairable. But otherwise the specs are almost exactly the same. They're designed to do exactly the same thing, to drive output transistors. So the right channel board has all of its original components except for the fuses. So they've gone through and put half-watt fuses in there, or fuses, resistors. I keep calling them fuses because some of them are supposed to act like fuses. I got a new toy. Thought I'd test some of the components that were in the amplifier. So here's one of the diodes. I pulled out. Let's see what it comes up with. It comes up with two diodes. Because remember, this is the one that was passing voltage in both directions. The other diode I think was just completely dead. Not passing any voltage. Let's find out. Yep, unknown. It's not doing anything. But here's a proper diode. Pop that in there. And there you go. That's what a proper diode, a replacement, should look like. So yeah, it's quite interesting that the one is passing voltage in both directions, and it thinks it's two diodes in there together. Now we've got the resistors. Obviously I can't read them too well, but there's a red stripe and a black stripe. So it's 200 something ohm resistor there. A little charred. Let's see if it survived. Still resisting. Still comes up as one. 208. Probably not too far off. Obviously I can't test the pieces or the two fusible links I've got here, but I've got this one, and this one is a 550. Let's see how the 550 did. It's a capacitor. Microfarad. It's a 95 microfarad with an ESR of 98 ohms. I don't think that's a capacitor. This one's really messed up. I was testing the right side first because I wanted to see if the new output transistors, sound a little bit, the new output transistors would work okay. And it worked great. Played great. And then, so, moment of truth, I would put the old output transistors from this module into the other module that was blown up, just to test with ones that I'm not going to end up using, so I don't blow up the new ones that I just got. But while I was disconnecting this, I disconnected the signal lines before I disconnected the power. And our main signal tapped this heatsink right here. Yeah. Zoom you on in. You can see right here the evidence. I know that module was working. Apparently we're getting no signal at this point. Out of that, I'm still getting a signal here. You guys can probably see it. I can't because I'm trying to get it to clip on. There we go. Clipped. Oh yeah. No problem there. Ooh. Let's poke around for some signal. In random places. Would you unclip yourself? What's there? Nothing. What's here? Nothing. Here? Nothing. Here? Nothing. Be able to see something without my hand being in the way. But I'm sure my hand will be, ow, in the way. That hurt. Thump, crash. Where things are. No, not that one. No. Oh, I need to see the other one. This one. Ah! Alright, what's the video looking at now? Check schematic. Which side of the schematic am I looking at? There should be something here. I have to look at voltages now too. Alright, let's break out the voltages. World's longest, crappiest film. It's going to be really fun to edit, won't it? There's no power. We're green. Pulling the dead resistor. .169 megohms. Yeah. Definitely broken. And only one way to find out. Let's see if this module. Okay. Trying it again. It's doing stuff. Okay. This one's working again. Good. What's missing? Trim pot. So I was testing the other amp board. I was testing the other amp board because, you know, I'm just trying to figure out what the heck is going on here. What's broken? And I noticed the resistance value on this trim pot was off. The one over here was adjusted to 160 and 160, 100, yeah. And this one was it 160? I forget. So I was just checking the other one, and this one was just slightly more than half the value of the other one. So I went to adjust it, and I pulled it all the way to the end of its adjustment, and it wasn't able to even reach the same point. And this is a 330 ohm trim pot, and it was only getting up to about 130 ohms. So I pulled it thinking, well, I guess the trim pot messed up. Nope. Once it was out and I tested it, it's fine. That diode is shot. The one that I thought was fine because it should read some voltage in both directions because it's going through the trim pot. Well, because the one and the other one did exactly the same thing. So I went, all right, well, voltage is going through the trim pot in one direction and then the other direction through the diode. Well, I take the trim pot out. This diode is still passing in both directions. Just like, I think it was either 503 or 507 was doing the same thing. So I'm going to replace that diode and maybe then it'll work. Also, before I forget, this is one of those cases where it seems to be fine when tested in situ, but when you remove it, it's going to test bad. So there are some instances where you can't test in the board, you got to pull it. And this is one that I just let go thinking it was fine, and well, alright. We're going to test this diode together. Yep. Look at that. Just like the other one we've got in there. 2 diodes. It's not. It's busted. Alright, time to pull the amp back out, plug it in, and see your 37,915. Ready to blow a fuse? Yep, still blew a fuse. So, you see where I messed up? Where I've just blew this up, thinking that diode would fix it, and yeah. Whoopsies. My dumbass put it in backwards. Let's see if the diode did it. Here, well, I'll turn off the tuner. Here goes nothing. Nothing's blown up. Woohoo! Now I can turn the tuner on. Sweet! Alright. Radio station? Music? Do we get sound? Apparently not. Now I'm multimetering it. This is the right channel that's working. I got my negative 60 volt rail, positive 60 volt rail. Left channel, positive 60 volt rail. No. Negative 60 volt rail. And these are independent power supplies. So there's a power supply issue. Obviously this thing has been blown up, so, well. Alright, let's see what we can do here. Our amplifier is on. And this would be -62. This is the right channel. -63. -63. Interesting. Why isn't it getting to the amp? It doesn't go through anything to get to where I was testing up above. Literally does not go through anything. It goes straight there. Let's just double check and make sure I hadn't suddenly decided to start working. Yeah. Let me just put it into DC voltage mode. Power is not making its way up through the amp board. We got it down here.
Plus get free delivery now.
Well, it turned out that the problem with this, with the negative channel, it was just the connector was broken. So it works.